Can you crank the light back on? Thanks, sir. Yeah. Not at the moment. For some reason, actually, the green book doesn't have any from 2.4. We put it all in 2.5, the percent stuff. Can somebody tell me everything you know about, like something like 10%? What does that mean?
10 over 100.
Beautiful. Percent means per 100. How many cents are in a dollar? 100 cents is from Roman centum. So Latin. So this is 10 per 100 percent. So 10%. If you reduce this, what do you get? 1/10. So if I say 10% of 40.
10 over 100 times 40.
Of means multiply.
40 times 40.
This used to be something everybody knew coming out of high school. Now it's the reverse. Barely anybody knows it. I don't understand that. It's a very simple thing. Of means multiply. So 10% would be 1/10, because that's what the hell 10% is, times 40. And what's that? 4. Yeah. 1/10 of 40 is 4. It takes 10 fours to make 40. So 1/10 of it is 1/4. Do you like it? Now, let's take this one more step here. What is I almost gave it away. What is 1/10 as a decimal? 0.1. Really, right?
Mm-hmm.
This is the tenths place, and then of course it would be the hundredths place, and so forth. So you could, 10% you can make 0.10, because that's 10 hundredths. But that 0 is really unnecessary for math. In science, it means something else. In science, this kind of gives an idea of how certain we are. The 0.1 guy is less certain than the 0.10 guy, but math says they're the same freaking number. What's wrong with you? Right? So 0.10 is the same thing as 0.1. That relates to 10 hundredths reducing to 1/10. Okay, let me stop for a second. Is everybody roughly with me at the moment? Yes, sir.
The 4 is a like exponent. Like, why is that there?
Oh, this?
Yeah.
No, it was just 10 goes into 40 4 times.
Oh, okay, cool.
Then 1 times 4 is 4, yeah.
Thank you.
You're welcome. It wasn't a phantom exponent. Sounds like a better movie than Phantom Menace to me. Okay, sorry. Okay. So we have this idea of changing percentages to fractions to decimals in all different directions. You with me? Let me ask you just straight up, how would you make like 56% become a decimal? Yeah. So the percent symbol means divide by 100. So the division hasn't happened yet when the percent symbol's there. So when you divide, the number should get smaller. And our number system is based on 10. So every time we divide by 10, the decimal just moves backwards. Because our number system is based on 10. You guys semi with me? No? Because 56%, 56 over 100, which would be 0.56, 56 hundredths. So really, you just move the decimal back. So right now, so here you move it back twice. I like it. I like it. So what I always tell people is if you put decimal and percent in alphabetical order, from decimal to percent you move that way, from percent to decimal you move that way. So here we went from percent to decimal, so we moved the decimal that way, back, twice. Why twice? Because it's all out of 100. 2 zeros. Stop. What would this be as a fraction? I think I already just wrote it. Yes, 56 over 100 as a fraction. Come at 56. So what I like to do is I like to give you these tables. Percent, decimal, fraction. And I'll have one thing filled in on each of these. Right? Something like this. And then I ask you to fill in the other two for each row. So 11%, what would that be as a decimal?
28.5.
Yeah, 0.11. You're gonna move it back one twice. And then as a fraction, it would be
11 over 100.
11 over 100, 11. Either from here or there. What about 3/5? How would you make that into a decimal?
Like 0.35.
0.60.
No.
0.60.
Yeah, because one way to do it is I can make it out of 10. I can make it a decimal,
Oh,
right?
Yeah.
And now if I make it out of 100, I can go straight to a percent, really. So 3/5 is what tenths? What I do, multiply by 2, right? Which is also known as 60 over 100.
Yeah.
What's 6/10 look like, decimal? 6/10, 0.6. 60 over 100 would be
60%.
60%. And that jives with moving the sucker once, twice. So they're just representations of an idea. We made percentages up completely. Now, we made every freaking thing up here, to be honest. I mean, why does one look the way it does? Because that's the way it Egyptians had their one look like that. It represented a rod. I love that their million looks like an astonished person. I just won $1 million, right? And their 10 is a scroll, and I know their 10 is a heel bone, and their 100 is a scroll. I can't remember. So I teach this class 120. Sometimes I teach 120, and I teach different number systems, like a ancient Chinese numeration system. There's 0, looks like a face sticking their tongue out. I love this. The Mayan system looks like pancakes and strawberries. That would be 12. Every pancake's 5, and every blueberry is 2. Is 1. So this would be 12, the number 12 in Mayan. You guys kind of with me? So I on one level, don't worry, you are kind of with me, even if you think you aren't. It's just a way, how do I represent the number 12? Well, this is how you represent it in mine. And this is how we represent it in our system. Right? Our system, by the way, is Hindu Arabic. That is the number system we use. But percentages were completely made up by Hume. We just made them up. It's a lot easier to think about 11% than it is to think about 0.11. Or if I say 0.005, I'd rather think 0.5%. Have a better feel for what that means. How are we doing so far? A little bit. Okay. You're like, you lost me at freaking Mayans. 0.002. What is that as a fraction? What place is that in? Careful. Tenths, hundredths, thousandths. Normally in this kind of table, I don't make you reduce. I'd rather you don't reduce, because a lot of you guys know where your fraction button is in your calculator. So if everything's reduced, I'm like, and what is that as a percentage?
0.2%.
Yeah, you move this sucker twice, so 0.2%. I like it. So I love that kind of problem.
For 3/5, how do you, to get to that, do you just always multiply by 2?
Well, not always. I multiply by 2 because it was 5 down there.
Okay.
Right? If I had 4 over 25, how would I make this into 100? Multiply by 4. Yeah. So it really depends on what's there and can I now what if I had 4/7? How do I make that into a decimal? Can you make the bottom become 10 or 100?
No.
Not easily. So how do I make this into a decimal? I do what this says. What does this say to do? 4 divided by 7. Now a lot of you guys somehow put a 4 outside. No, that would be 7 over 4. This is 4 divided by 7. Right? So it would take all this. That's how you make it into a decimal, and then you can just move the decimal place to make it into a percentage. So I love this interplay between fractions, decimals, percentages. And you're like, of course you would, Jeff. You're a math. Okay. Now, so that's one idea there. This idea of conversions between all the forms. Okay. Then let me ask you this. Percentages freak people out because they don't act the way we think they might. If, let's say like back in the day I was making $10 an hour, right? My first job I was making $3.25 an hour. But, gas cost 80 cents a gallon. Yeah. Okay, Jeff. Some of you guys can beat me on that, maybe. A few of you guys that are at my age or older. Now, let's say I make $10 an hour, right? And I get a 10% pay cut on my check. Am I happy? Am I happy? No, man, what the hell? So effectively, can anybody tell me then what pay rate I'm getting? I was getting $10 an hour. They gave me a 10% cut. Yes, because 10%, remember 10% is 1/10? So 10% of 10, 1/10 of 10 is 1. So I got $1 less an hour. I'm now making $9 an hour. So I was making $10 an hour, which sucked already, and now they're making it $9 an hour because 10% of 10 is 1. I lost $1 an hour. So I go and complain, and they're like, oh, wow, sorry, Jeff. We'll raise your pay by 10%. Move along now. Being a math guy, I'm like, screw that shit. I'm staying right here. Because I know it ain't going to get me back to where I was. So 10% is not equal to 10%. It depends on the base. What is it of? So if they increase my pay by 10% now, well, what's 10% of 9? It'd be 1/10 times 9 is 9/10. It's 90 cents. So now they made it go from $9 an hour to $9.90 an hour, and that 10 cents an hour, that will freaking add up. When I was making $3.25 an hour, a 7 cent per hour increase is like, ooh, yeah, relatively big. So I'm still going to be upset. So 10% does not equal 10%. This is a mistake related to word problems. So if I had a, let me ask you this. If I had a hat, if there's a hat, I don't know why it's always a hat, that is on sale for 10% off, it now costs, what, Jeff? I don't know, dude. It's a freaking hat. $12.40. What was the original price? So this is a classic kind of problem. Just to outline the mistake people make. They take 10% of $12.40 and they add it. That ain't never going to get you back. What did you take 10% of to get here? And was the original price higher or lower than this?
Higher.
So you took 10% of a bigger number to get to here. So 10% of this is never going to get you back. Does that make sense? It's just like the 10%, and it got back to $9.90. No. Bring my ass back to 10, or else tell me what the hell I did wrong, right? You guys semi with me? So right now I've just identified the biggest mistake people make. We haven't talked yet about how to do this kind of problem, right? This would involve variables, right? If you wanted to use full algebra to do this, which we're in algebra class, you probably want to do that. So tell me, real quick, if the hat costs $16 original, so this has nothing to do with this problem, except I'm trying to feel this out a little bit. I'm going to give myself an answer. Let's say the original was 16. I'm not saying that's the answer. I'm just saying, let me just try it. Let me just think about this. How would you figure out what the sale price is? Yeah, so I have to figure out what the discount is. It'll be 10% of 16. All right, so 1/10 of 16. Yeah, $1.60, I love it. You just move the decimal back once when you divide by 10. So $1.60, let me put another 0 in there to make it money. Now what do I do with that $1.60? That's not how much I got to pay to get the hat. Don't get overly excited.
16 minus a buck.
Yeah, 16 minus $1.60.
15.40.
Oh, 14.
What's 16 minus $1?
15.
Then you got another 60 cents to go down. Come on, let's get that much done, right? No, don't take it wrong. A lot of people do the same thing you just did. But if you think about it for a minute, this is more than $1. So take $1 off and then keep going from there. So do it in steps, right? Just to make it make sense. What I really hate is this change comes out automatically now almost everywhere. And that was one solid place people had to get practice with their math, and I'm like, so I have to know the original to be able to figure out what the sale price is. Well, up here, what the hell's wrong with that? Do I know what the original price is? So what are we going to call it?
X.
X. And then I can do shit. So instead of 16, put X. I don't know what I don't know what it is. So well, I'm going to do 10% of X. And then I'm going to subtract it from X. Oh shit. So we'll do that kind of problem again. We'll do that more of that obviously tomorrow. I'm out of time now, but okay. We go to 12:25, right? Yeah.
Yeah.
I'm still trying to get used to this. So I'll have the quizzes graded tomorrow. And we're going to get into a lot of word problems. Our next quiz will probably be either Wednesday or Thursday. So we'll talk more about that tomorrow. Yeah, dude.
I forgot to turn on my spectator.
All
I
right.
showed all my work on.
Okay.
I was trying to get your attention, but I didn't want to interrupt you.
Oh, you can interrupt me for this kind of thing.